Welcome to the September edition of Trends in AI. It's a very special edition, but we'll come to that in a second. My name is Jakub Zavrel, founder of the company, and really excited about what the summer has brought us. We've taken a bit of a break. We skipped the August edition. So we have doubled the amount of material to cover in the same time.
Yeah, and it's been quite a lot. AI doesn't stop.
And with me is Dinos.
Hi everyone, I'm Dinos. I'm an AI researcher at Zeta Alpha and host of the Trends in AI webinar. So yeah, I think we should get started.
Absolutely. So it's a special edition because it's our birthday as a company, 5 years of Zeta Alpha. Yay! We made it. It's not officially the 5th anniversary of the webinar. I think that will still take a few years. And we have lots of stuff from breaking news, little fruit on the top right. Just came out yesterday. We'll dive right into that. News, gossip, models that are released. It's been a real treasure season the last few weeks.
Yeah, and as usual, the top 10 research papers that we cherry-picked according to our popularity metrics and monitoring of social media.
Yeah, the research papers that we think you should really know about. So the breaking news came yesterday.
The elephant in the room.
We were kind of following the rumors about strawberry. And yesterday, I think it was 6 o'clock in the evening here, right? It finally came. So there's a new super powerful OpenAI model called
O1, surprisingly.
Not GPT.
Just O1.
Yeah, is O the same O as in GPT-4o?
Who knows?
OLMoE. So it's called O1, and it's a really strong model in reasoning. And what's the trick?
Well, I'm sure that it wouldn't delve too much into it.
It's a secret.
It is a secret.
So we're going to speculate a little bit.
Although they do have some hints on how this model does reasoning better. Basically, it's an entirely new training paradigm with a reinforcement learning objective, where the model is kind of trained to reason more about its actions before it...
And it's taking its time, right? It's not immediately answering, but it's actually thinking first and then giving an answer.
Which is not new as a research.
Yeah, I mean, chain of thought is with us already for 2 years, right? So essentially, it's doing a chain of thought.
Right, and we also showcased in this show a few months ago this system 1 attention, system 2 attention, and all these works that kind of do this reasoning, reflection, all these kind of adjacent paths to get the answer before answering.
Yeah, and it was introduced online by Noam Brown. So I've interviewed Noam Brown. He's a master of reinforcement learning. He did all this stuff around poker and Stratego and other games with reinforcement learning. So my guess is that reinforcement learning is indeed a very big part of the recipe. These graphs really show you how much of an advance it is, particularly in math, right? So this model goes in a very competitive math benchmark from 13% correct answers to 83. Well, that's for the internal AGI achieved model. The one that we got is 56. That's the preview model. So apparently there's a yet more powerful model that has not been released yet. Yeah, and beating on science questions, kind of PhD level human answers. Also very good on coding. Not good for everything, right?
Yeah, it's not a generalist like 4o is.
Yeah. So if you're just using a GPT model to to summarize your email, it's probably not going to be much better with this new model. And so the idea is that it's kind of a new paradigm of scaling up.
Yeah,
right?
But
inference time scaling.
Not in the usual sense.
Not in the number of parameters, not in the size of the training data.
Or the model.
Or the model size, yeah. or how long you train it, but it's actually shifting the compute expense from the company to the customer, right? So the longer you think, the more tokens it generates. I think you pay for them actually as a customer. Yeah.
And I think it's their most expensive tokens, output tokens that they've ever had so far.
The tokens that you don't get.
Yeah, it's first of all, they report that the model is trained to have a ratio of 4 thinking tokens to 1 answer token.
Yeah.
And I think if I remember correctly, it's $60 per 1 million output tokens. So for reference, I think 4.0 is 30.
All right, so only try it on math and PhD level problems that are really like good value for money.
Yeah, I want to point out how in this scale, the x-axis is log scale, which is the time it takes to think, but the performance isn't. So
yeah, it's linear on a log scale, but still, I mean, the fact that you can continue going up on that, it's a new thing, right? Mm-hmm. How does it work?
Well, we don't have that much information, but I managed to find this in an OpenAI developers article. So not the main blog post, but more of people that are integrating this model, will be integrating this model into other workflows. And they kind of show that what the model does basically is it has its own internal monologue, and like chain of thought pretty much. It's just thinking about the problem, the task, the input, just to solve it better. But now they decided that they won't be showing this to us. In fact, what you're getting is kind of a model-generated summary of what it thought behind the scenes. And then that also obviously helps it reach a better conclusion. And yeah, from a few of the developer snippets and the researcher interviews that they did, they share a bit that there is a reinforcement learning model, and that's also undergone a lot of scaling, more than they had for the reward model in GPT-4. But still, they don't disclose that much on.
They didn't publish any technical information, no paper.
But there is a model card, which is huge, but not.
But in our top 10 papers of this month, we discovered another paper, not from OpenAI, which explains exactly how this model works. Stay tuned.
Yeah, you have to stay tuned for this.
Yeah, pretty exciting. On Twitter, everybody is going nuts about this. There was another completely different dimension of AI being touched in the news. There was a report by Mario Draghi published this week about the future of European competitiveness. And well, basically the bottom line is we're not doing great in Europe. We're falling back, falling behind with respect to the US and China in terms of our productivity, competitiveness, and innovation. And basically, this plan by Draghi is intended to launch a huge investment initiative. I don't know if he will manage to pull it off, but he proposes to spend around 750 to 800 billion to boost innovation in Europe.
If I'm not mistaken, this is tech in general, but obviously there are hints that AI should be where we have a chance to basically catch up.
Yeah, so data centers is lost for Europe, but AI is still an opportunity. And he's basically afraid that those companies in Europe which are making a dent in the universe are going to otherwise go to the US, which might happen. Who knows? And to illustrate the point of Draghi, here's a recent selection of European AI news. So the European autonomous AI champion, Aleph Alpha, out of Heidelberg, Germany, has just last week announced that they're stopping the production of new large language models. It's too expensive, and the ones that they're making are not keeping up with the competition. So they're turning now into a consultancy company for German corporates. In similar news, the Finnish European AI champion, Silo.ai, was actually building a Scandinavian languages alternative to GPT. It happens to be on the Finnish supercomputer cluster, which has AMD chips. And very soon after that, AMD bought the company. Yeah. I guess it's no longer a European company. They kind of argue they still are, but so is Google Zurich, right?
Yeah, and DeepMind.
Exactly. The much hyped French startup called Ash, or as we say in English, H, formed by former DeepMind and Meta research engineers, is already kind of in trouble.
Yeah, I think we covered them in July or June.
Yeah, they got like 200 million seed investment. And there were 5 guys who got 200 million, and apparently they couldn't agree how to divide up the the proceeds of that. I don't know. Nobody knows what happened. Operational differences, but they quit again. So that's pretty spectacular rise and fall in 2 months or something like that. Over the summer vacation, they just got different ideas. Well, fortunately, it's not all gloomy for Europe. We still have Mistral. They'll come in the cool parts, cool releases section. GraphCore, a European chip startup, was also sold to SoftBank for less money than what the investors had put in. So I think Draghi has a lot of work to do. And what was that with the iPhone event?
Oh yeah, I think
last week. It was also last week, right?
Yeah, it was
Apple Intelligence on the iPhone.
Yeah, I think this tweet really summarizes pretty nicely. Everyone gets AI on their fingertips all over the world, but in Europe, we'll have to wait until the Digital Act Committee and whoever is responsible in Apple to kind of figure it out. That's yes, we're responsible enough and we can have this technology. Yeah, and I think this juxtaposition of these 2 tweets just puts it everything that needs to be said.
I don't know if that's photoshopped or it happens to just come together.
Sometimes the algorithm just knows.
Exactly. So GraphCore is no longer the hot chip startup that it once was. Do we still have any left? Well, I think NVIDIA is dominating the news about AI. 2 weeks ago, they came with their latest quarterly earnings report. I think they more than doubled the quarterly earnings over last year. Yeah, pretty stellar financial results from NVIDIA. And an interesting detail in that report was that actually about half of their revenue comes from 4 big tech players.
Who they also happen to be investing in.
I don't know.
In some way or another.
It's probably Microsoft, Amazon, Google, and who's the 4th one?
Maybe Anthropic?
We'll come to a really big new cluster of GPUs being launched. But there are serious contenders. For example, in South Korea, 2 very exciting AI chip accelerator startups are working to develop a true NVIDIA alternative under sort of Samsung and SK Hynix investments. And we have a lot of the Silicon Valley based. So Grok obviously made a big splash by launching a really fast inference service. So they're not actually selling their chips, but they're, and if we can do inference really fast for a lot of LLM type workflows, it will make a big difference. And they recently got a pretty large investment, $640 million, to build that out. And Cerebras thought if they can do that, we can also do it. And they launched, in fact, the fastest inference service at the moment. So for I think this is a Llama 8 billion, Llama 3.1, 8 billion model, they can do 1,800 tokens per second on their hardware. That's pretty.
Yeah, and I think I saw also a response
it's more than 2 times faster than Grok.
I thought I saw a response from Grok saying that, oh, we can squeeze a bit more, but yeah, it's also your mileage might vary. Yeah.
And just a few days ago, Sambanova also launched a similar inference service. It's not as fast as Cerebras, but pretty fast. So a lot of stuff happening on the AI hardware side. On another more analytical side of things, we have updated our research on that. So every quarter, we count how many mentions there are of different AI hardware vendors in AI research papers. And it's a very good way to keep a finger on the pulse of that. So we see that NVIDIA, this is also log scale, by the way, the vertical axis. We see that NVIDIA continues to dominate and grow. But there's a couple of interesting developments there. Still in the very low numbers, Huawei is growing fast, and Apple, of course, with its neural engine, is really being adopted, especially since PyTorch now also runs on it. And I guess Google now requires all their engineers to mention the word TPU in their research paper. So we see that there. And here we have the other big NVIDIA customer. So Elon Musk announced that they brought the Colossus supercomputer online at XAI, and it has 100,000 H100s. That's a lot of compute.
Yeah, and
how much does that cost?
They're being put to use, I'm sure, and we'll cover a bit of this in a bit.
I think it costs enough to make up for one of the 4 in the NVIDIA report. One other thing that came out was Llama 3.1 in the middle of the summer. It's already been ages. One really interesting graph from that, kind of related to AI hardware, is they have a nice table. It's a very good paper, very detailed.
Actually, research paper.
Yeah, detailed research paper about what it takes to actually get a model of that size to a good quality. Here they tap the failures during training, and they're actually almost always GPU failures. So if you're training at the level of 10,000 GPUs, the chance that your training run will complete without error is almost 0. And I'm really amazed that NVIDIA can be so dominant and produce such faulty hardware, actually. All right, from the smaller hardware startups, we see Grok all of a sudden appearing on the chart here, the light blue line. And also Cerebras is doing a really good job in getting researchers to use their hardware. So you see that the commercial success of these companies is somewhat correlated with research adoption. Right, so startups and funding. This is a very long list. We'll just kind of do the highlights.
Yeah, this wouldn't be a regular episode without a bunch of billions raking in left and right. But I think the most important and striking one here is none else than the former chief scientist at OpenAI, Ilya, who started a new company with a very interesting name called Safe Superintelligence. And I think he managed to convince that he was the brains behind all these GPT releases, and raked in $1 billion in investment.
And both things don't exist yet. Superintelligence doesn't exist yet, and safe AI doesn't fully exist yet. So his plan is to just spend that money to invent those things. No products planned, right? What else is interesting? A lot of investments for AI startups in the code space. Basically, support tools for developers to become much more productive. There was a lot of buzz online around what's it called, the Sonar. sorry, Cursor.
Cursor.
Yeah, that's AnySphere and a bunch of others, Magic and Codium, also getting pretty large investments. What else do we see? Some acquihires, Character AI and Covariant, both kind of folded and sent their team in a now well-known recipe to a big tech company with some damages being paid to the investors. And yeah, a bunch of other good funding rounds for Sakana, for Contextual, for Glean, and for a new European player, actually, Black Forest Labs. It's the more or less the complete founding team or the complete engineering team of that built Stable Diffusion. And now have a new company called Black Forest Labs. And I think they helped Elon Musk create a kind of a censorship-free image generator. So brace yourself for the coming elections. Model releases, lots of them.
Yeah, and
where do we start?
Some feel quite distant. I think there was this was mid-August, but I would swear it was the beginning of summer. But yeah, all that GPU hours and money to NVIDIA culminated in the Grok 2 release, which I think is already live on for X subscribers.
It's pretty competitive.
It's a pretty competitive model, but I like this visualization to actually show you where it ranks, because it's I don't know, 50 numbers don't tell me much, but that graph does. And I can tell you before you scan this table that the most performant model is usually Cloud 3.5. So they don't claim state of the art, but it's still a very good model. And I think it shows how fast this company has grown to. I mean, they have top talent, obviously, but still they're producing good artifacts.
Open source.
Yeah, and the open source. I mean, we've known Hermes from the early Llama days. They just do a really good job on fine-tuning on both real data, instruction data, and preference data nowadays. So Hermes 3 is the newest and greatest fine-tune of Llama for all kinds of sizes, 8, 70, and 400 billion parameters. Yeah, they consistently or closely match or outperform the base model. And I think it's permissively licensed, so this is definitely a good one to use in an application where you're caring about the output, the chattiness, and actually does quite well in more hard number benchmarks as well.
Jamba?
Yeah.
It's not a transformer model, right?
Yeah, it is in this new family that we've covered, which is Mamba, and this is I think AI2's, or is it? Yeah. They have two variants. These models are typically very good at having faster inference because you don't have this attention mechanism. So in that blog post, they also emphasize quite a lot on that we're faster, we cannot be matched with transformers, but also on the performance side, it matches Llama and other open source alternatives. And so yeah, this model is for people that want to play around with that kind of models. I don't think they're close to state of the art, but they're not marketed as such.
And we don't only have cool language model releases, but also multimodal models. I think the one that's getting the most attention and fan testimonials is QN2, 72 billion parameter multimodal model, which I think beats GPT-4o on quite a lot of benchmarks, right? So
yeah,
it's pretty amazing for
I don't think
it's
just benchmark. Also, real life use, people are reporting quite positive.
Yeah, so it does text, video, and speech.
I'm not sure. Does it do speech?
Or only
I think it's vision for sure. The VL stands for, I think, vision and language.
So only vision and language. All right. Yeah, and it's open source, right? Then from Microsoft, Phi 3.5, a much smaller model trained on high quality data that is also quite competitive. Yeah,
it's actually a family of models that they released, and the one we're highlighting here is the Vision variant. Yeah. Obviously, all the big model releases now have some image encoder into the pipeline to handle images input.
And finally, just
2 days ago,
2 days ago, Mistral dropped their first multimodal model called Pixtral. And yeah, in typical Mistral fashion, they only dropped the magnet link on Twitter, and that was it. That was the marketing campaign.
Yeah, we don't have a blog post yet with the capabilities of the model, but I've seen some screenshots from pictures from some private events they hosted, and they compared. It's along the lines of Quen, but so not that much better. But yeah, we have the weights. People can
But it's
use
a lot
it.
smaller, right?
Yes,
So
yeah.
it's like 7 times smaller. So Europe is not doing that bad after all with Mistral, because this is their production for the summer. So while the guys at H were quibbling in the streets of Paris about how to start a company, Mistral actually delivered 4 pretty impressive models.
Yeah, another one 2 days ago. So these were, I think,
5. Yeah.
I think these were just from August, or maybe August and a bit of July. So we're seeing here Mistral Nemo, and this is kind of the distillation technique that NVIDIA proposed, using both synthetic data and all of the tricks to get the model, I think, 12 billion parameters, which is permissively licensed. And on the other side, we have the large 2 model, which is their proprietary one. And they dropped 2 other models on the same day, which are kind of more specialized for other tasks, namely code generation with CodeStrawl and math problems with MathStrawl. Yeah, and on all benchmarks, you can see they're quite good for their size compared to other open source alternatives. And I noticed that the private one, Large 2, they quite also marketed for coding, even though it's a generalist language model. Most of the blog post was about its coding capabilities. It's pretty cool.
And Mistral Nemo is actually the backbone of this new Pixtral model. And we have not only generative large language models, but also embeddings models. So those are not being measured on the LLMs arena, but mostly on MTEB. And we can proudly announce that we've released our first open model. We didn't make it to the top spot yet, but in the top 10. And yeah, that's kudos to the Zeta Alpha team who are here.
Yeah, quite a challenge to beat NVIDIA with probably 1/1000th of the GPUs they have, but still, I think a decent act. And also not just the model. I'm not sure if we're the only on the top 10, but one of the few top models in this leaderboard where you can have a look and more details about the training. Most of in our production efforts, we've reached out to people and they've not been very clear about how they train these models. So our focus on this one was also a lot on showcasing how these models are trained, what data do you need, open sourcing that data, other evaluation tricks that we use to develop these.
Yeah, so there's a blog post on our website that gives you the entire recipe of how to do this yourself. So next week you can be up there. And hopefully we'll be further already. Work in progress. I think we're of the top 10, we're not super GPU poor, but we're the GPU poorest of them all. All right, so those of you who haven't heard about us yet, we started 5 years ago with building a platform for AI research scientists to organize their papers and discover new information, keep up with the archive firehose. And that has resulted in a pretty widely used platform where you can find new research papers, organize your stuff, share it with others, and get recommendations. And since then, we have evolved a lot, actually. And now our main business is actually in deploying that platform for proprietary knowledge, especially in very knowledge-intensive and high-tech companies. And we have built this whole platform, which is a multi-tenant RAG and Agentic AI platform on proprietary and confidential data Yeah, if you're interested in that kind of thing, get in touch. We have some interesting product releases to announce next week when we have our big yearly conference, but I won't speculate about that yet. So we use our platform, of course, also to make this this webinar and to select the papers that we are going to discuss in the next research section.
Yeah, and this past month we've seen quite a high variety of topics. We won't touch on all of them, but we're clearly seeing now how AI is also being used in other domains. Here at the bottom, we see computational biology, molecular design, medical imaging, which is kind of what are all the big releases from also big labs are
AI for science, basically.
They're coming from.
That's really growing very fast.
Yeah, you'll see that our collection focuses mostly on these large language models and the vision models, but we also have some more exploratory papers that we found that were kind of more ambitious on what you can build with AI. So yeah, let's move to the top 10.
The top 10 list. This is our top 10. You can find the list on our blog also, and of course, as a shared tag in Zeta Alpha. We'll give the link to that
in the video
at the end. So let's dive into it. I was really super excited about this paper, ColPali. So ColPali is a basically a combination of two ideas. One, the Colbert idea in information retrieval, which does retrieval at the word level with embeddings at the word level,
and also late interaction
and multimodal large generative models. And basically this paper kind of promises to change the way information retrieval is done altogether. So the classical way to do generative AI on private documents is to actually, for example, if you have a PDF, to first do all kinds of pre-processing steps on the PDF, so that you go from the binary format into a text format, and then chunk it into sentences and little paragraphs. And it's really important how you do the chunking, and then you do all kinds of natural language processing on that, and eventually end up embedding these chunks. And this paper does something completely different. It just throws the images of the document, the actual bitmaps of the pages, into a vision language model, and takes basically patches from the image, and the visual embeddings of those patches just get stored in the search index. And here in this graph, you can see that compared to the traditional approach to indexing PDFs, which for this data set takes 7 seconds, this only takes about 1/3 of a second. But how can you search them? Well, that's where the beauty of Colbert comes in. And basically, the query is language, right? It's words. So these word embeddings from the query are compared to all the visual embeddings, and they happen to be aligned by the multimodal model underneath. And you retrieve basically image patches from your index that are aligned with these query patches.
Obviously, they're fine-tuned for this, right?
Yeah, they fine-tuned for this in the Colbert way, using a fairly large synthetic data set. And the amazing thing is it works. It works really well. Look at this. So here, to be completely clear, this is a benchmark that they constructed themselves, so other people still have to replicate it on this benchmark. But here you basically see ColPali at the bottom with an average score of 81 versus roughly 17 to 50 for clip-based models, which do a single embedding per document. and around 65 for more traditional sparse and dense retrieval methods. And we did an interview with Manuel Fais, one of the authors, and he points out that what he's particularly proud of is here, this shift task where they match the 73.2% of the BGE model, but it turns out this shift task is completely non-visual. So this is a completely text-based retrieval task, and still with these image patches, they can get the same result. So yeah, that's pretty exciting.
Yeah, and let me tell you, there's a lot of hype around this kind of architecture and libraries popping up left and right on social, on GitHub, on everywhere. Yeah, because I'm not sure. I mean, it has obviously the same drawbacks that Colbert has, and I think it's at this stage it still hasn't obtained this level of quantization for the embeddings and optimization that's needed to productionize it.
It's a first prototype, to be honest.
It's a very fresh idea,
and we have an interview with Manuel Fais that will be out very soon. All right, so ColPali. The next paper on our list is also an information retrieval paper.
Yeah, and I was actually quite enjoyed the reading through this one. It's called RouterRetriever, and the premise is to kind of bring not exactly the technique of how mixture of experts work, but the idea of having different embedding models trying to encode a single query with different ways, depending on which expert is better at encoding it.
So what are some examples of different queries that go to different experts?
So they're using the Beer benchmark as a foundation, and they claim that you have financial domain in there, you have Wikipedia articles, you have more generalist information like MS Marco. And what they're doing is they're fine-tuning experts on the train sets of these data sets, basically creating one expert on each domain. So they group together all the data sets about Wikipedia and create one expert on that. And then each expert kind of creates a collection of pilot embeddings. And these pilot embeddings are kind of the centroids of the data sets it was trained on, which kind of signifies that this expert is really good on this domain. So when you encode the query with a base encoder, like Contriever is what they use, they see this query, where does it land on the on the embedding space, and
where's the biggest domain overlap?
Exactly. So they find that, for example, a query asking about financial regulations, it will be probably closer to the FQA expert, and so it will use that expert along with a mixture of the base encoder to produce the embedding. And here in this table, they show that it performs quite well on the domains it's been trained on, but also they find that a few interesting insights that also just adding more experts leads to better results. And the way that they're doing this, the way that they're doing this a mixture of experts, which is not the classical way where you're just passing it through a network, which you have to train this router. Since this is kind of a bypass where you encode the model, and however many experts you have, you can just scale this process similarly. They find that just adding more experts usually leads to better results. And they also compare this obviously against, you can just take the model and fine tune all the data sets on the same model. But as we know, this is very tricky and leads to often catastrophic forgetting. So just by controlling on the data sets and also number of training samples, they show that this model performs the best in terms of efficiency in consuming these examples. Obviously, there's still a gap because this mechanism is kind of, you can see it has been engineered, but the gap to the best expert or the Oracle expert that routing that says, okay, this is the best embedding, there's still some discrepancy there. So it can be 1 point to 7 points NDCG, but I think it shows that still it's much better than just training on all the data sets or just using a generalist model on MS Marco. Pretty cool work.
Nice. So let's move to the next one. I'm having some trouble with the slides here. Right. This is a model, a paper, sorry, by a bunch of people from Google DeepMind. Scaling a large language model test time compute optimally can be more effective than scaling model parameters.
Sounds familiar.
Sounds familiar. So this group of Google researchers wrote a paper of about 20 pages which explains in great detail how the latest Strawberry model from OpenAI may work, right? Not based on analyzing the O1 model, but based on their own experiments, which basically kind of investigate this whole continuum of how much you invest in training the model and how much you invest in searching the output space during inference, right? And so what are some ways that you can search the output space during inference? Well, of course, you can just let the model generate different outputs and then maybe do that in parallel and then pick the best one, right? And for that, you need a kind of other model which evaluates the potential of that output. So it's kind of a reinforcement learning like setup already, where you have a model which is able to evaluate what the generating model is creating. And once you have that setup, you can take it to great lengths. So here, you really have to read this paper to understand all the different variants. But something like chain of thought is just the variant of that, right? You're just creating a kind of prefix of a path and restarting the generation from there. So if you remember your diagram, that's kind of one of these iterations. And then you can let the evaluator model do a tree search from there. So it's kind of also reminiscent of tree of thought, if you remember that.
Yeah, in the critic model where we've seen language models critiquing the output of the others, I think all of this comes into a more solid.
Then, of course, if you combine it with kind of using this evaluator model also during training, then these models become kind of end-to-end quite good. So basically, they show the same kind of improvement graphs here, that if you increase the computation budget during inference, then you get a pretty linear improvement on a logarithmic scale. And they also show that you can use these kind of tricks when you have a reasonably good small base model that actually doing this kind of inference time scaling allows the model to beat a much larger, 14 times larger model, where that same compute was equivalently spent on training it.
Yeah, which is pretty good for open source, right?
Yeah, absolutely. So fascinating read. Check it out. This is more a nuts and bolts paper, but I think one that will soon be adopted by every large language model. So as you know, probably the attention mechanisms in transformers is the bottleneck to scaling the architecture, right? It's quadratic in the length of the sequence. And there have been very smart people tinkering with GPUs to kind of help a little bit. The first one was flash attention, which I think already made it 2 to 4 times faster. Then we had flash attention 2, which made it another 2 times faster. And now we have from Tridao, who was also the guy behind. He's basically the sort of the nuts and bolts genius who makes all of deep learning run.
The kernel wizard.
And they noticed that flash attention 2 only, with the latest generation of NVIDIA GPUs, it only filled the pipeline to 35%. So 65% of the H100 GPU was kind of idling, bottlenecked by all kinds of memory confusions. And so basically with this flash attention 3, they managed to fix that and get the utilization of the hardware back to 75%, using tricks that would take about 3 hours to explode. There's an appendix, and it contains basically a GPU machine level instruction explanation of how this works. But I think my prediction is within a month, everybody is using it. All right, a little bit more fluffy, systems-oriented, cognitive science type of paper now.
Right. I think this is quite an ambitious paper, and I like the idea behind it. So this paper proposes what they call a framework called automated design of agentic systems, and they implement one algorithm that has a meta agent. And this meta agent, as you can see here, basically tries to find an idea, implement the code for an agent that solves the problem, and then evaluates that agent on the task that it was tasked with. And then what is interesting, and I think it's pretty novel to this idea, is you save all these models and you use them as reference for future agents that you build. So it's kind of like you have your assistant that is an AI engineer, writes some agent, and then collects experience over time on how these agents perform and how you can build new agents more sophisticated, with more sophisticated designs. And I mean, the argument here is, all of the AI progress has been originally very handcrafted features, and the analogy here is the prompts are very handcrafted and we design them for the tasks, but ultimately if you have an efficient way of searching through the search space, the model should be able to find the right solution. They have this quote in the paper that since Python is Turing complete, then they should be able to just let Python work until it finds a solution. And actually, to their credit, they have so this is a prompt. You can see it's a typical prompt that they supply the meta agent with, saying you're an expert machine learning engineer, you're going to write this code, you're going to use some framework, which is, you can imagine, LangChain, to solve this problem in this domain, input, output examples, stuff that you would actually do to solve, to create an agent.
Right.
And I like this think outside the box, be innovative and all that stuff. Yeah, so what they benchmark it on is a few math tasks and reading comprehension tasks, and also this notorious hard arc task. And you can see how this agent basically in this figure shows how over iterations, it builds better agents. Like first it tries to figure out what this data set is about. Then in a few agents down the line, it has some breakthrough where the accuracy goes up. Yeah, so for the example here, it discovers that chain of thought helps, even though the model hasn't tried it at first. Then you add dynamic memory and all this kind of stuff so you can see how this little mini AGI, you can see the analogy also to Voyager and Toolformer and all that kind of work. Yeah. But there they only had a tool scope, but now you kind of say, you can have an agent as a tool and all the agents you've built in the past.
Yeah. Well, obviously, as we're building these, super multi LLM agentic workflows, we're not going to write them by hand, right? There was another paper or release, this 1,000 agents, which together developed a kind of economical system and a society in a Minecraft world. That was also not scripted, right? It's purely emergent. Very nice work. So this is also another use of AI agents.
And I didn't notice it at first, but it's also some of the same authors. And this made quite the rounds on social media, kind of a freaking out of, it's called an AI scientist, and it writes paper on its own. But it's not as impressive as it sounds. I mean, they propose this as an idea, but they don't mean it as we figured out research. So what they propose
is a thought experiment.
Yeah, it's an experiment.
What if?
Yeah. So you can see this quite nice and detailed pipeline of how they produce the papers. So first, obviously, you give it an inspiration, like, I have the transformer model, or I have a diffusion model. And then the model kicks off from there, and it tries to figure out new ideas to improve the baseline. And
actually doing the work, right? Or like writing the code and doing the experiments and all that.
First it checks, is this addition novel? So it has access to an API that checks for papers on this. If it is novel, then it does another part that we'll get back to later. But if it's deemed that it's worthwhile, it will write the code, execute the code, fix the code, and all that stuff.
Write the bugs. Debug the code,
experiment, get the results,
write the paper, get it into review, then discover the bug, then go back and try to solve the bug, but then the results no longer all that stuff, right?
Actually, you're not far off, because they have some case studies and they see that, we have some bugs in the code, and the manuscript had the bugs, But what they also introduce is this kind of model paper evaluator, still fully
the reviewer is part of the researcher.
Yes, so they find that this reviewer
is that reviewer 1 or reviewer 2? Actually, that is.
I think it's reviewer 1 because they say most models are quite over optimistic, so they're not as harsh as they should be. So not reviewer 2. But overall, they show that there's quite a correlated result performance with human annotation. So they use this iClear 2022 open review data, and they show that you can tweak the prompt so it accepts the paper when a human would accept it if you calibrate it correctly. But yeah, they show that this whole pipeline, basically, you get these scores, and it's building on the previous paradigm where you have the papers that you built in the past, and then you use this to iterate further and make better papers, kind of similar to how you do in real life. But one of the limitations that they show is also they compare this to an early stage career researcher, and they check the papers. They have a case study on 3 quite interesting papers, but they say that, yeah, it's very naive, and maybe they draw explanations out of things that don't hold.
Yeah.
So I like the blue part, where it helps you brainstorm with ideas, but the execution part, I would say it's still not there. It's good to draw some ideas from, but I would not use it to write a paper or review one.
Yeah, so this is the paper that does the work, who creates the ideas. That's a paper we didn't put on our list, but it also came out just last week. So there was a large-scale study at Stanford in actually generating novel research ideas. And I think the answer is to this question, can LLMs generate novel research idea, is yes. It was found to be as good as a group of NLP researchers, although the model, the LLMs excelled in creativity. They did not match the human researcher in feasibility. So kind of big ideas, but one that the previous paper could not execute yet, maybe. So we're getting to the end of our list. This is a very big paper from Google DeepMind for those people interested in more computational science, and especially in drug discovery and creating new proteins. So Google announced this system called AlphaProteo, which is kind of a follow-up work to AlphaFold. They use AlphaFold to generate the training data, and this is still a more efficient generative model for proteins from that. It's also this kind of generator and critic setup. And the critic is particularly important because you can generate lots of molecules, but to really do drug discovery, you have to take them into the lab, and every failure there is super expensive. So their main claim in this paper is that they are able to achieve very high success rates in turning these in silico prototypes into actual working molecules in the lab. Up to 88% success rate. Well, that's one particular task. And for those of you who are interested in this kind of compound and drug discovery, there's also a very cool paper called Generative Hierarchical Material Search, which does something similar, using graph neural networks to actually generate different crystal structures for new compounds like solar cells and other battery materials and things like that. I think we have to just mention this one, OLMoE. It's
I think
open model by LNAI and contextual AI, right?
Yeah, so for the remainder of the papers, let's just show what the main idea is. And here is none other than just replicating all the work that closed labs have done on creating mixture of expert models. So this is an open reproduction using datasets that OLMoE had used as well, DOLMA. And they, what I like about this paper actually,
wasn't Mixtral open by,
but not on the way it's been trained. So this model, this paper is a research paper that has all the ablations that they did on what hyperparameters you want to use, design choices, and so on. So it has 1 billion active parameters of 7 total. and it's quite performant. It outperforms obviously everything that's on that kind of range, but also even larger models like DeepSeek and Llama 13 billion. Yeah, so this table I would say is the money shot. All the insights and conclusions that they drew on how to design this mixture of experts architecture.
The detailed tricks. This is more a nice novelty paper. Nothing really shocking, but this group of researchers basically managed to train a network to act as the game engine for Doom. So basically used AI agents to play Doom a gazillion times, collect the images from that, and then fine-tune a stable diffusion model to generate the next image in the game, conditioned on the action of the player. Pretty cool. Human players were not able to tell the difference between the real Doom engine and this neural one. And last, but not least,
this is another vision model, foundation model from Meta Reality Labs. It's a foundation model for human vision centric tasks. So you can imagine pose estimation, body part segmentation, pose detection, the normal surfaces, and so on. So yeah, the trick is pretty similar actually to Dino, what we had covered before. Meta just found the technique and keep scaling it. So good data, manually curated, high quality filtering and so on, and obviously an architecture that can scale well. So they're using a Mastodon encoder to pre-train on this quite suspicious data set. They say proprietary data set of 300 million human pictures. I'm not sure where they might have found that.
From Meta. I don't know.
Yeah, but it's
on TikTok maybe.
It's an open model, and it does quite well. It outperforms. I'm not sure if I have the numbers here, but you can find in the paper. It's an open model that does pretty much state of the art on a bunch of tasks. Yeah.
So that brings us to the end of the list, and as always, we close with something slightly strange. So, conspiracy theories. What is your favorite conspiracy theory?
One related to fruits. There was this rumor going about.
So, you might have noticed that in the last few weeks, leading up to today, there was an enormous buzz on the internet about GPT not being able to count the number of R's in strawberry. It was debated fiercely, right?
Yeah, and I think OpenAI just embraced it.
And my conspiracy theory is that this is the best marketing campaign in the world ever, leading up to the strawberry model. But if you're interested in conspiracy theories, I will try this over the weekend to cure me of this one. There's a cool article in Science that chatbots can help to persuade people to stop believing in conspiracy theories. I don't know if it works over the weekend. I'm also kind of curious if it can stop them believing, and it also
make them.
Right. So that brings us to the end of our show. The next event is not Trends in AI October, which will also be here, but the next event is Transformers at Work. And we thought, because we've done it 4 times here from Science Park, let's do something different when we're doing the 5th anniversary. So Transformers at Work is next week, Friday, but it's live from Berkeley, California. And we have a pretty stellar lineup of 8 fantastic speakers. Actually, Dao Kila from the OLMoE paper, Natalia Vasilyeva from Cerebras, and Hyun Dai talking about the LLM retrieval work at Google, and many others. And we're gonna have a party there. And you are invited if you're in the neighborhood. And if you're not, you can watch it online. We'll be streaming everything.
If you don't have anything to do Friday night, I think it's 10 p.m. here.
Yeah.
But it will be recorded. So
it will be recorded. So psyched for that. And as always, have a great weekend and enjoy Discovery.
Thank you.